Okay, guys, so I want to talk about the 2017 question 9. Now, this is a sample answer I've done out for it, and I did make one slight mistake when I was doing out the sample answer that I kind of go through as we're going through the question. Now, for part A, there's actually 5 parts to part A. So it's a reinforced concrete strip foundation supports 400 mm concrete block external wall with an insulated cavity as shown. Using notes and freehand sketches, show a typical design detail of the foundation. Include the position of the reinforcement in the foundation. Specify 3 typical dimensions and discuss the reasons for the dimensions you have specified. Okay, so you've notes on the foundation, sketch on this foundation, the position of the reinforcement, 3 dimensions, and discuss the 3 dimensions. So here's just our standard strip foundation. I've just drawn it really quickly. If you have colour pencils, it'd be way better if you could colour it in. Maybe if you want to put in your area of block here as well, that'd be a good idea. But there's just your standard strip foundation. So there's my notes done, or my sketch done on it. Now, I didn't, when I was doing this question first, put in any notes. So I've just put some notes on a separate page. Yeah, so strip foundations, just about them in general. They're used in soils of average to good bearing capacity. They are the most economical type of foundation. When the load of the building is being applied to the foundation, it spreads out at 45 degrees. So kind of like I've done down here in the drawing, the load being spread out. If the foundation is not wide enough, there may not be enough pressure to support the house, so it could cause the house or the wall to tilt slightly. If the foundation is too wide and there's no steel in the foundation, it may shear off the edges. So my edges of my foundations might just actually break off totally. So there's my notes done for my foundation. My sketch done. So then it was 3 typical dimensions. So first one I've talked about the width of the foundation being 1,200 millimeters. So the width of the foundation must be 3 times the width of the wall. So my wall is 400, it says in the question. So I have 400, 400 and 400 for the wall that is being built on it. This is to spread the load over a wide area. So just a small few notes. The reinforcement cover of 50 millimeters. There should be a minimum of 50 millimeter cover around the steel reinforcement. Why? This is to prevent water getting into the steel and causing them to rust. What happens when it rusts? It expands, it contracts, and it could cause your foundation to weaken. Then, the third point I have is the depth of my foundation. So the depth of the foundation must be 600 millimeters below the ground level. Typical the foundation is 1,000 to 1,200 below the ground level. This is to prevent the frost getting down to the soil at this level. This will stop the ground expanding and contracting. So if frost gets down below my foundation level, the frost will cause the clay to expand. Then it will contract, expand, contract, weaken the soil around my foundation, and it will weaken the house. Okay. So there is 20 marks going for that question, 4 for the notes, 4 for my sketch, 4 for the drawing of, on the drawing showing where the reinforcement is, 4 for 3 dimensions, and 4 marks going for discussion. So we've got all them 4 marks. Right, part B, using notes and freehand sketches, discuss the importance of each of the following to ensure the maximum strength of concrete in the foundation. So again, using notes and sketches, so we have to do both for each. So, first of all, mixing. So when you are mixing the cement, make sure that all the aggregates and water do not have any dust on or dirt in or on them. This will reduce the strength. The smaller the aggregates, the weaker your cement mix will be, but it will be easier to work with. So it's a fine balancing act that you have to kind of go along with the whole time. And I've just done a very quick sketch just to basically get my sketch marks of cement, sand, water, and if you wanted you could put in the ratio of these, so 4:1 or whatever kind of mix you're doing, depending on whether you're putting down a foundation or whether you're putting down a floor in a house or whatever it is. Then talking about placing. So placing the concrete, extra water can be added to the cement mix to make it more workable. This will reduce the strength of the mix though. When the cement is being placed, it should not be dropped from a height, as this will cause the larger aggregates to sink to the bottom and the smaller aggregates to go to the top, especially if the cement has been watered down. So that's why I mentioned the water down part up at the beginning, and I brought it back to the very end. And then I've just done a quick sketch of your cement coming in from your cement mixer, dropping it from the height. And then if you drop from the height, we'll have our large aggregates at the bottom and our smaller aggregates across the top. The opposite over at this side. So if it's dropped from a much smaller height, I'll have all the aggregates kind of mixed together evenly throughout the whole thing and can make it more strong, add more strength to it. Compaction. So it is important that when the cement is placed, it is compacted so that any air pockets can be removed. This can be done using a tamping beam or a mechanical vibrator. Careful consideration must be taken not to over vibrate as this could cause separation. What I mean by separation is the aggregates again could sink to the bottom, the bigger aggregates, and the smaller ones go to the top. Or if you hit against the side over here, or if the vibrating rod hit against the side of your former, it could cause the former to vibrate so much that the aggregates would move away from it, reducing the strength. So here's a quick sketch of just former around a U-shaped former and a vibrating rod pushed down. I should probably have a cement level kind of drawn down. And then the other one is just a tamping beam. So I have a beam going across what's a big square concrete pad basically, and you just tap that around. Next up is curing. So curing is a process where concrete continues to gain strength. This can last days, weeks, or even years. In the initial stage of concrete is poured on a warm day, it should be covered to stop it from drying out too fast, or water applied. If the concrete is placed on a cold day, it should be covered. Sorry, there's a mistake in there. It should be water should be applied to stop it from drying out too fast. And if it's a cold day, it should be covered. So here I have my water spread on top of my concrete mix, and here I have my concrete mix and some sort of cover put over on top of it. In olden times, they used to just put straw just to stop it getting in, but there's other materials nowadays you can put into it. Part C of the question is, using notes and freehand sketches, discuss one test that may be carried out to measure the consistency and the quality of concrete delivered to a site. So there's really only two tests you can talk about here, our slump test or our cube test. So I've just talked about slump test because I kind of know this one a little bit better, and it's just kind of an easier one just to talk about and you get lots in about it. So notes and sketches, so I have to do both. So here's just my notes on this page. Apply oil to the inside of a clean mould. Place the mould on a level surface and apply 3 equal layers of the cement mix. Tamp each layer with 25 strokes of the rod. Remove any excess concrete on top. Rise up the mould slowly and straight up in the air. Measure the slump. The height of the mix should drop down, and then the greater the slump, the weaker the cement. If you do, say, you're pouring a foundation and you get 3 lorry loads worth of cement, all the 3 lorry loads should have the same slump test results. So here are my sketches for my slump test, really quick and simple ones. I have my mould around the outside, 1 layer of cement in, 2 layers of cement in with a tamping rod, 3 layers of cement in. Then I pull up the mould and my cement comes out the side. And then I have my third is the slump where it comes down. And there's my cement that has kind of fallen off. Okay, so a couple of points for this question. Like this question has taken me, so I had half a page on the notes. 1, 2, 3, 4, 5 pages just to get that much in. The level of detail you need to put into your answers is a lot more than what you're currently putting in. So you need to add a lot of discussion about each one. One-line answers aren't enough at this stage, especially if you're going for a H1 or something, a good mark like that. So go over this, pause it, stop it, look at it again, but just look at the amount of detail that goes into each question. Okay, thank you.